Hey guys, welcome to Algebra 2, Lesson 1A.2. Today we're going to solve quadratics by factoring. So I'm not going to read the steps here that are outlined in this box. I'll just talk you through the examples as we get to it. I'm sure you remember a lot of this from geometry last year and Algebra 1 the year before that. So the first thing we want to do when we're given a quadratic is to set it equal to 0. So we want to get everything over to one side. So in this case, obviously, we're going to add 12 to both sides. So after we do that, we get x squared minus 7x plus 12 equals 0. Then we factor the left side. So in this case, we have a trinomial. There's no GCF. We always check for GCF first, but there's no GCF in this case. My first term is going to be x and x. That's pretty straightforward. Now remember we said about our signs. If the last term is positive, that means our signs are the same. And in this case, they're both negative. Okay, so we can put those in now if we want. And now very quickly, again, you can do this in your head. I'm going to write it out for notes. We need the factors of 12. 1, 12, 2, 6, 3, 4. Now remember, both of these are going to be negative. You can put those signs in. But basically, we need the pair that will give me a 7. So that's going to be a negative 3 and a negative 4. Now, once our polynomial is factored, now we need to come up with the roots. Now, there's a very quick shortcut to do this. I'm just going to show you guys in this first example how we get the two roots. But basically here, we set each factor equal to 0. It's called the zero product property. So there's one, and here's the other. We're going to really skip this step moving forward, but I just want to remind you guys where we're getting these answers. So one root is x equals 3. And then from the other one, we add 4 to both sides, and then that's going to be x equals 4. So from here on out, we're really going to skip this step. I think you can go from the factor directly to the root. It's kind of an easy shortcut. You notice if the factor is an x minus 4, the root is the opposite of what you see in the parentheses. So that's why this gives me a positive 3, and that gave me a positive 4. All right, our next one. Looks a little bit different. It's already set equal to 0. So how do we factor that? It's not a trinomial. It's not the difference of two perfect squares. Oh yeah, GCF, right? GCF is always the first thing you should check. So let's do that. They both have an x. We'll take it out. We'll divide both of those by an x. Remember, that's how you get the terms that go in the parentheses here and here. So if we do that, we get x minus 8. Now, set each factor equal to 0 and solve. Here's the nice thing about a GCF. That root is always a 0. I don't care if there's a 2 in front of it, a 5 in front of it. I don't even care if it has an exponent. The GCF always gives you a root of 0. So I've got x equals 0. And then using the shortcut that we just talked about in example 1, this other root's going to be x equals 8. Now notice this one says check. Well, how do we check it? Well, you just take the root and you plug it in to the original equation. Always go back to the original. Don't do something that you've already done a little algebra on because maybe you made the mistake on the way there. So we'll plug that in. So I get 0 squared minus 8 times 0, and that has to equal 0. Well, obviously, this is 0, and that's 0. So, yep, that one checks. The other root is an 8. So if I plug that in, that gives me 8 squared minus 8 times 8, and that has to equal 0. Well, that's 64 minus 64, and that's 0 equals 0. So, yep, I checked it. Both roots work. Let's go on to number 3. So remember, the first thing we should always check for is a GCF. And indeed, there's a GCF here. So let's factor that out. Divide both of those by a 3. That gives me x squared minus 4 equals 0. Now, this is my favorite factoring technique, difference of two perfect squares, x squared minus 4. So we got 3, x minus 2, x plus 2 equals 0. Now, this is interesting. Up above, I said the GCF always gives you a 0, but remember, that's only if there's a variable in the GCF. That's going to be x equals 0. Notice the difference here. This is just a 3. There's no variable associated with it, so there's no root coming from that. A quadratic has 2 roots. 1, 2. So there's no root that comes from that. All right, so that would give me x equals 2 and x equals negative 2. You can also express this as x equals plus or minus 2. Some of you might have recognized another technique you could have used that doesn't involve factoring. Square root method, we'll talk about that a little bit later. But that's probably the easiest way to do it right now. All right, number 4. What I'm going to do here, we've got to get it equal to 0, right? So I'm going to subtract 5 from both sides. That'll give me 2x squared plus 9x minus 5 equals 0. This one's going to be a little bit more challenging to factor because of this 2. So let's come up with our 2 sets of parentheses. And not all trinomials factor. This one's going to, but we'll get to some later in this unit that don't factor and talk about some other methods to solve that one. Oops, sorry, it should be 2x. It's 2x and x. Now, I have a negative 5 there. Somewhat easy because my only factors are 1 and 5, and I recognize that my signs have to be different. So a little bit of trial and error. 1 here, 5 here. Let's see what happens. That's a 1x. That's a 10x. I need a 9. Oh yeah, that'll work if this is positive and that's negative. So put a negative there and a positive there. Now, this is a little bit interesting. This one is. Looks a little bit different than the other factors. So let me just do the one I know how to do right away. This root will be x equals negative 10. Remember where that came from. All right, let me just scroll back up here and show you the zero product property. You set the factor equal to 0. Here's my factor. If there's no leading coefficient, that's super easy because I just take the opposite of that number. Well, just a little bit more challenging here. Set the factor equal to 0. Well, now let's solve this. Add 1 to both sides. I get 2x equals 1. Divide both sides by 2. I get x equals 1/2. So there's also a pattern to finding that root. If I have a leading coefficient, my root is the opposite of this number divided by that coefficient. So I'm really not going to show that anymore. I'm going to take this and say, oh, it's the opposite of this, so that's a plus 1, or just 1, divided by whatever number that is, 2. So there you go, 1/2. Now, if that's a little bit confusing, obviously you can still just set that factor equal to 0 and solve. All right, here's some that are a little bit more challenging. Example 5. I've got more than one term I need to move over to the other side. So maybe in this case, I will take a moment to actually write this out. I don't want to try and do too much in my head. So this will give me 2x squared minus 2x minus 12 equals 0. Now I'm going to do something a little bit different here than I did on the other one. Notice that there's a GCF of a 2. So you can factor that out. Let me show you that other page again, what we did. You can factor out that number. It's called a constant. I just kind of leave it there and then recognize that there's no root that comes from that. Or, if it's easier for you, you can actually divide both sides of the equation by that number. You can always divide by a number. You can never divide by a variable, though, so don't make that mistake. This gives me x squared minus x minus 6 equals 0. And now this is just much, much easier to factor. I'll go through the factoring process quickly here. I have x and x. A couple things I notice. My signs are different. I need factors of 6, 1 and 6, 2 and 3. The signs are different, remember, and you need a negative 1. So that's a positive 2 and a negative 3. My two roots that come from this will be x equals negative 2 and x equals positive 3. Wow, 6 looks interesting. How are we going to do that? Who remembers what you do when you have a proportion? Well, we've got this handy little method called cross multiplying. The product of the means is equal to the product of the extremes. So I'm going to multiply those two diagonals and then set them equal. Again, I'll just go slow. It's the beginning of the year. So this is what it looks like. I won't actually multiply them out yet. So it's just a matter of distributing on both sides and then moving everything over. So let's see, over here I have x squared plus 7x. And now here I'll distribute a 3x. 3x squared plus 3x. Now, depending on what order you did this, I usually want my greatest exponent to remain positive, so 3x is over here. I'll take a second now, I'll subtract x squared from both sides, and I'll subtract the 7x. Doesn't really matter what side the variables are on, could be the right, could be the left. So I get 0 equals 3x squared minus x squared is 2x squared. 3x minus 7x is negative 4x. Now let's take out a GCF. They both have a 2, and they both have an x. So take out a 2x. That gives me an x. Take out a 2x there, and I believe that gives me a 2. So now, what are the two roots? Well, this GCF contains a variable. I don't really care about the number, but I do care about that variable. So if there's a variable in the GCF, that gives you a root of 0. And then x minus 2 will give you a root of 2. Now I'm just noticing here that this one said check over here. I'm going to skip that step for now because we're going to talk about how to check things graphically. So to check graphically, you want to find the intersections. And there's really two methods to do this. I'm just going to create a simple equation here real quick. How about 2x squared equals 2x plus 12? And in Algebra 1, maybe depending on who you had, one teacher said, oh, always set it equal to 0. Another one said use y1 and y2. You get the same results either way, so it really comes down to personal preference. Each one has an advantage and disadvantage. So if I want to put this into y1 and that into y2, the advantage of this method is you do zero algebra. Whatever you see in the equation, you put those into y1 and y2. Now, unfortunately, I can't show you my calculator, but I'll just sketch it quickly over here. Here are my axes. This is y1. So I'll write that in and put y1. And then y2 kind of looks like this. So what I'm doing is I'm finding 2 points of intersection. This one here, I'll call that P1. That one there, P2. Now in the calculator, remember you do second calc intersect. And what you're going to do is you're going to move your cursor and it'll say, graph 1, boom, hit enter. Graph 2, enter. Guess, and then just move it close and hit enter. So on your calculator, it must say intersection. Then what you do when you get those coordinates, you just write them down. So the coordinates for P1 are negative 2, 8. And my coordinates for P2 are 3, 18. Now here's where it gets a little bit challenging. The coordinates are not the solution. Why is that? Because look at the original equation. It only has x's. You are solving for x. So the solution will only be the x values. So now I'm going to write x equals negative 2, x equals 3, and that is my solution. There is another method. I am not going to confuse you with it right now, but the other method of doing this, if this does not look familiar to you, would be to move everything over to the other side. So you've got a quadratic here equals 0, and then just put this into y1. So then you would only see one parabola, and you look for those roots. We'll get into that a little bit later. All right, so that concludes day 2. As usual, any questions, please do not hesitate. Go up to the math clinic, come in for some extra help. Thanks a lot for watching, and we'll see you soon.